Basic RFID hardware consists of interrogators, also called readers, antennas, and tags. Interrogators generate RF signals, which are transmitted by the antennas. If a passive tag is within an antenna's electromagnetic field, it powers up and communicates back to the interrogator. The process is different for semi-passive tags and active tags. The antenna's area of influence is known as the interrogation zone. More than one antenna can be placed around an interrogation zone to maximize the chances of reading a tag. An antenna is a conduit that emits and receives RF signals. When a tag responds to an interrogation, it transmits its data that is picked up by the antenna and sends it to the interrogator. The interrogator processes this signal and then forwards it to a host computer. Typical interrogation zone configurations are portals, arrays, and tunnels. In this module, we'll focus on how to design and configure an interrogation zone so that passive tags are read quickly and correctly. An interrogation zone, also known as read zone, is the region around an antenna or an antenna array that has enough RF energy for a passive tag to communicate. The read range of an interrogator is the maximum distance between an antenna and a tag at which the signals from the tag can be read properly. Interrogators also have a write range, which is the maximum distance at which information within the RF signal from the reader can be received correctly by a tag and successfully written to the tag's microchip. Even though the signal may be distorted, an interrogator's electronics has enough built-in logic to decipher a tag's communication. For writing to a tag, signals need to be undistorted and clear, as a tag's electronic circuitry is not sophisticated enough to decipher distorted waves. Therefore, the write range is generally 50 to 70% of the read range. It's important to note that the read range and the write range will differ between equipment manufacturers. The read range and the write range also depends on the tag's ability to pick up energy from the antenna RF field or the tag's Q factor. We could flood the interrogation zone with RF signals and expect 100% tag reads, but the input of RF power to an antenna is limited by regulations. For example, in the US, an antenna cannot emit a signal stronger than 1 watt. Therefore, you have to find ways of focusing more RF energy within the interrogation zone while not violating RF emission regulations. Since metals reflect RF, one could place suitable metal screens or mesh around an antenna so that more of its energy is directed within the required interrogation zone and not elsewhere. The efficiency of an interrogation zone is enhanced by the selection of antennas. For example, if you know that the tags are placed at a particular orientation on cartons coming down a conveyor belt, it's important to choose an antenna with the corresponding polarization. Simply, if you don't know the tag orientation, you need to ensure that the tags fall within the antenna fields and that the antennas are at the right heights and correct angles. A more focused interrogation zone indicates higher chances of a tag falling into a region with high RF signal strength. This in turn means higher accuracy and reliability in terms of reading or writing to tags. When writing to tags, accuracy and time are the main issues, since writing to tags is a slower process.